Hey, Lyle.
Hey, Clemens.
How's it going?
Good.
Well, thank you for coming over here to the wonderful building 43 we're in at Microsoft, to the Service Bus team, and letting me speak to you about some things that I think are relevant specifically for using Azure Service Bus in the enterprise. So we have a lot of customers who are using Service Bus. You can go to, if you're not familiar with what Service Bus is, you should go to the Azure site and familiarize with it yourself with it. But it's an enterprise message broker. So if you're moving workloads from on-premises into Azure, you will find with Service Bus a super robust equivalent of well, IBM or RabbitMQ or Apache ActiveMQ Artemis, whatever you're running, you find a managed service inside of Azure. If you're already using Service Bus, there's a few things I'd like to talk about in this video in terms of advice for how to use Service Bus today. Like if you are a loyal customer already, a few things that you might want to go and consider putting onto your backlog of things that you might want to go and change, and then also some general hints for optimizing your implementation. And that's mostly informed by us seeing support cases coming through, customers asking us very common questions, and so I'll talk about some of those. So the first thing is we have announced and released a new client for .NET Standard recently. So far, certainly our strongest footprint in terms of coverage for client landscape has been in .NET and .NET Framework. And so what we've done is we created a brand new implementation of our client library. We took the chance to make some cleanups of the API. Most of the changes that people need to go and make to their code are simple mechanical. I just translated all the samples that we had, like the whole sample set, from the .NET Framework to .NET Standard. And it wasn't really hard. So the brokered message is now called the message, and some of the properties changed and stuff. But it's fairly simple. The advantage you're getting out of this, and this is why we're encouraging you to switch and do that work, is that new library is fully based on AMQP. AMQP is a asynchronous protocol, standard protocol that has been built specifically for messaging, and it's much faster than the prior legacy protocol that was the default in the .NET Framework client. So the .NET Framework client speaks AMQP, but you have to go and ask for it specifically, and so the new client only does AMQP. What we also did is release a client for Java that looks structurally identical. So if you have been using guidance that we had on the site until just shortly, that was mostly driving you to a Java API that was built on HTTP. We also encourage you to go and adopt that Java client. And both of those are, if you want to find them, github.com/Azure, Azure-service-bus. That's where all the information is about the clients, and you'll also find the information for how you find the Java client on Maven and how you find that new .NET Standard client on GitHub. AMQP is the primary protocol that we use for Service Bus as well as for Event Hubs. It's the other service that we have, and you're going to talk to Dan about Event Hubs. And so we encourage customers to go and really buy in on the AMQP side. What we've done with AMQP is we made it firewall friendly using WebSockets, so you can go in and talk from and to Service Bus using that protocol, and it's an open protocol that we are directly engaged in driving. I'm now the co-chair of the Oasis AMQP Technical Committee. The other co-chair is Rob Godfrey from Red Hat, and we're working together to make all the products of all the companies which are engaged in AMQP work better together, so that you can use a small on-premises broker for your purposes of a branch situation where you have restaurants or a gas station or anywhere, or a local store, anywhere where you need to have some local information flow, and then you want to go and integrate that with the cloud, a classic hybrid scenario, to make sure that that all works smoothly. That's why we're doing all that AMQP work. In terms of another thing that comes out of that AMQP engagement is that we're getting much closer with the Apache Cupid Proton project. We're now adding samples. That's also in the same repository that I just mentioned. Not only for our own Java client, but we're also adding more and more samples for JMS. And what we're doing there is we're effectively electing to use the Apache Cupid JMS client also as the JMS client for Service Bus, and that's something that is uniquely enabled by two things. First, that we're using AMQP, and second, that we're also engaging in the effort to go and standardize effectively how JMS binds over AMQP into brokers, and that we're implementing the necessary backend facility to go and make that work. So that if you're targeting from a Java application or Scala application a broker using JMS, you'll be able to go and use on-premises broker X, and then you'll also be able to go and use Service Bus. There will remain some differences between those, and we're aware of that specifically in the AMQP community, and we're going to make those things align, so that customers who are bringing applications from retail, applications from the financial industry, applications from travel into the cloud will have a robust and universal messaging infrastructure that they find in the cloud, that they don't have to operate, and that we can operate for them at extremely high availability and higher availability than they can realize today on their own infrastructure. And that effectively the experience that they have will be preserved. In terms of a few little tips and tricks that we see out of support cases or customer engagements. So we have, specifically in Service Bus, we have two offerings. One is Service Bus Standard. Service Bus Standard is a multi-tenant infrastructure with shared resources, which means you create a namespace that's the equivalent of a broker you would set up for yourself, or a broker instance in another broker. And inside of that, you have your topology, your queues, and your topics. But in standard, that is all riding on shared infrastructure, shared storage, shared compute, and the tenants, so the namespaces, are effectively a virtualized concept. What that causes is, so that is very cheap because we have economies of scale, and we can go and host tens of thousands of these workspaces on the clusters that we have. Just for the clusters, when I talk about clusters, we're talking about 64 machines that are working effectively as one. In the smaller deployments, we have deployments that go up to 128 machines that make up one cluster that then hosts those namespaces. The downside of that shared model is that if there's a neighbor namespace effectively that shares some resources with you that pushes a lot of traffic, your resources might be impacted. So the reliability will not go down, but your performance may have exhibit some significant jitter. And to smooth that out and to have predictable performance and even higher reliability, and for us to be able to give you features that are compute intensive, which we currently can't do in the shared resource model, we have Service Bus Premium. And Service Bus Premium is what we recommend effectively for all customers who are having significant and high reliability workloads. And where performance is, predictable performance is imperative, because there we have a cluster in the cluster model where we actually, depending on how much you buy, we call these messaging units, 1 to 4 messaging units, where you can go and reserve capacity for yourself. A messaging unit is similar to what SQL has a notion also of the database, these database units. And a messaging unit gives you some compute. I'm not going to say one core because that's not correct, but it's kind of in that area of, and then it gives you some allocation of memory. And what you can do with that one messaging unit is about 4,000 messages per second in one direction if you use no features effectively. So and then as you're adding use of features, then of course you're using more CPU, and then your throughput is going to go down. But that ring-fast resource will always be predictable, which means that's reserved for you. So if you get 700 messages per second for a particular scenario today, you're also going to get those tomorrow. And that's something, that predictability that customers have been asking for and that we're giving them with Premium. So that's the Premium is the better choice. Once you have predictability, then now we can talk about performance features and how to go and optimize performance. One of the things we see is customers coming to us and they are starting to pick up the product, and then they're doing some micro benchmarks. And that's the favorite discussions that we have, because we get emails from our colleagues in the field and emails from support and say, this customer has been trying the following thing and is dissatisfied with the performance. So a common pattern that we see is that customers come and send 10,000 messages in a loop, and then go and receive 10,000 messages in a loop, and then measure throughput, performance, latency, any of those factors, and then say, well, that's terrible. It turns out often their code is rather terrible, and that's causing a lot of the disappointments that we see in the customers. So one thing that happens is customers do, if they're using the .NET framework, they're using synchronous sends, or they're using await, send async. And if you do a await of an async sync, then what happens is that you send a message over to Service Bus and you're waiting until that message has been settled, which is kind of the HTTP model of how you would think about those things. But it's not the AMQP model of how you would think about those things, because that's a asynchronous protocol that will settle asynchronously. So what you'd rather do, and that's something that we also have in the product documentation now, under the heading of message settlement in our documentation how-tos, is what you would do is you would go and start 100 sends, and then you would collectively wait for those 100 operations to complete. Because the way it works is, though all of those sends are being pipelined, so they're being put on the wire, and they're traveling to the broker, and then the broker actually goes and accepts all those messages, and then in a summary settlement goes and sends those settlements down to the client. So you can go and settle 100 in one go, or you will have 100 messages which flow completely asynchronously back to the client. I can send, so just as demo, I usually work from Europe. So the furthest away from me, like the biggest latency I can construct is if I put some workload into a data center in Australia. From my seat in my house, effectively, to an Australian data centers is about 300 milliseconds round trip time. If I do these synchronous sends, well then, every send will cost me 330 milliseconds, which is like 30 milliseconds for the actual send operation that we do. And the settlement operation that we do, and then 300 just for the network, just because speed of light and it crosses tons of cables. So if I do 100 messages that way, it's going to take 100 times 330 milliseconds, and that's quite a bit of time. If I initiate those 100 sends and then just wait for all of them to complete at once, that whole operation takes 350 milliseconds. So you just need to do those things right. You really need to think about what you're doing and what you're putting on the wire. And we see this specifically in scenarios where customers are using Service Bus kind of as the backend for all their branch integration scenarios, where latency really matters. And so you need to if you embrace the asynchronous nature of the protocol and the stack that we built, you can build enormously performant applications that are far, far better than HTTP if you just understand this asynchronous nature and embrace it. And that's something that we is hard to kind of put into people's head only by writing it into the docs. Like that's something a message that we need to reinforce. In the clients, and we do this in Java and in .NET alike, we have chosen to have effectively two layers. One is the layer that we call queue client, topic client, subscription client. And then there's a lower layer, which is the message sender and message receivers. On both of those platforms, and we're going to go and have coverage for official clients for other languages. We're working on that with priority. We're going to have Go. We're going to have Node. We're looking at having Python. And then from there on, we're going to look at having other languages. If you have those languages today, you can use the Proton. That's, again, the benefit of having AMQP. You can use the Apache Cupid Proton libraries with lots of language bindings to go and interface with Service Bus, and some of those bindings even have Service Bus samples already. But if you use our official clients, you'll find very similar constructs. So those clients and those senders and receivers. The senders and receivers are lower level constructs, and we encourage everybody to use those clients. The clients are forcing a particular consumption model. So for instance, usually when you build a messaging-based app, you have a receive loop that you implement. So you run, you get a message, dispatch that message somewhere for working on that message. Typically, the work happens on that receive thread because you don't want to go and overstuff your thread pool. And then once you've done that work, you go and get the next message. That receive loop can go wrong in hundreds of ways, and can also be implemented wrong in hundreds of thousands of ways, like causing too much traffic, making wrong assumptions. So with those queue clients and the subscription clients on Java and .NET, what we're doing is we're effectively giving you a callback model where you can say, register a handler, we're going to run the receive loop for you, and whenever we have a message, we're going to go and call you, and there's some extra options for that. That is by far the preferred model over you creating your own receive loop. So we're doing a lot of work there. Another problem is, and that is something with very pronounced with distributed systems of that size, Service Bus does in the range of about 500 billion transactions per month. When we talk about event hubs, what Dan will do, event hubs, which is just for telemetry information, now does 1 trillion messages per day. But 500 billion per month for a transactional message broker is very substantial for that sort of infrastructure. And even with a reliability rate of 99.998, and that's where we are. So we're very close to having 5 nines in reliability rates factually, which is different from SLA. SLA means this is what the lawyers allow us to give you as assurance, but then there's our service level objective, like we really reach. But if you have a rate like this, that still means that you have, at the rate of 500 billion transactions per month, you have millions, hundreds of millions of errors. Just because the systems are very dynamic, because there's stuff happening all at the same time. We run upgrades. There's a lot of stuff that's going on in clusters of that size. They're breathing monsters. And so there will be transient errors where you're trying to send to a queue. That queue is currently moving from one machine to another machine because of load balancing or whatever. And so you're going to have an error. 1 out of every 10,000 message sends. That's what that really means at reliability number. Or actually, where we are now, it's 1 out of 100,000 will fail, but it will be recoverable. So what those clients do, what the lower level things don't do, they have an automatic retry policy built in. So if a send fails because there's a transient thing happening, we'll just retry. The receive loop, if that sees the transient error, it'll just try again. They will go and swallow all those things, and that's stuff that's difficult to handle if you go lower level, specifically if you go right down on the AMQP stack, if you use the AMQP stacks directly. And that's something that we do kind of with our product knowledge to go and say, that error happens, and we know about this and we log this, but we're going to let you go and do your things without disturbing the flow of the application, because it's something that the application shouldn't be using. So the higher you go up in the stack, the more of our client surface area use, the better it is. So also for Java, because we don't own the JMS client, and it's difficult for us to kind of get, all logic in there. We do suggest that if you build high reliability applications, that you really take a hard look at our Java client as the primary choice. Some other things, something that's very simple. Another one tip that I want to give is applications tend to do surprising things with messaging, and sometimes applications have bugs, and we have often customers who come horrified that messages have been lost, where we then find that the messages have not been lost, but they have been tried too often, and they've caused some mayhem inside of the application where that application started crashing. Once we have, and this is a settable, a configurable option, but the standard is 10. If we give you a message 10 times, we move that message to a construct called the dead letter queue. That is not known well enough yet, because we find plenty of customers who are still surprised by that concept. If you give us a message into the queue and we acknowledge that message, we will not lose it. If you have not given us permissions to remove it, we will not remove it. Permission to remove comes in two forms. One is TTL, time to live, that you set. And the other form of permissions is that the client, the receiver, explicitly settles it. It says, I'm done with that, it's complete. And otherwise it lands in what's called the dead letter queue. So one of the things that we encourage customers to do is to have explicit handling of the dead letter queue. The dead letter queue is something that works just like a completely normal queue. And you can go and receive from it, and every queue has one. And what we see is that customers don't observe those properly. They don't handle those properly. And so that's something that customers should go and look into as an explicit thing. Yeah, and then lastly, what's important specifically with, or I think fantastic with the queuing system that we have, is that the ecosystem is pretty broad. We're now introducing, and the combination with other services. Microsoft Flow and Logic Apps both have absolutely fantastic integration with Service Bus. And if you need an integration, for instance, from, let's say, Service Bus to IBM MQ, so you have an existing on-premises installation, you have, let's say, an IBM mainframe set up even, and you want to go and talk to that mainframe, pull data out of MQ, and then put that on Service Bus for a cloud solution, then Logic Apps has that pre-built as a capability where they can go and integrate with MQ, sending and receiving, and then route that information to Service Bus. And we're integrated, obviously, also with all the other pieces. So think of Logic Apps really as the integration at the edge, and Service Bus as the information mover then within and in between all of your applications. So that's a great integration piece. Another integration piece that we're now about to release is the integration with Event Grid. Dan might talk about that some more, but there's a common pattern that we see where customers are having queues that are just used occasionally, that see just a few messages per day, or that see messages on certain times of day, and where they basically would have to see an idle listener that just sits there forever for hours and hours and doesn't get to see a message. And that obviously costs them. So to eliminate that cost of just sitting around idle, one of the integrations that we now do is with Event Grid, where The condition is if there's a queue and nobody's listening on that queue, and that queue goes from no messages to having messages, we're going to raise an event on the grid. That event on the grid can then be received by a subscriber, which will then go and start out that receiver so that you can go and start processing. And then once you get no messages for a minute, you just shut down that receiver again. And then once that queue changes state again, you can go and pull that up. So it gives you effectively this serverless integration for a enterprise class message broker. And then finally, if you have Service Bus is a feature. It's a feature of Azure, but it is a service in the sense of we want to help you doing more things. It's not something that is far away. The way you go support, give us feedback, the way you give us, you ask for features, is to simply raise a support request on us. And that's what I would encourage enterprise customers to do if you have an agreement with us specifically, because then you already have a support agreement and all those things. Feel encouraged to file also support requests that ask questions or that suggest features, because that's the way how we make the product better. And we have much more agility as a services team to create new features than a team that goes and ships box product. And we're always looking at legitimate requests. We will not be able to fulfill every request, but if you have a great case and we can see that case is useful for others as well, that it has a good chance that we're going to go and put that on the backlog and then also realize it. So feel encouraged to go and use the support request channel also as a way to get a feature request in front of us. That's what I had.